Okay, welcome back, students. So yesterday was a short class we had, but no issues. Today we're going to cover up a bit, and today we're going to learn about the hexadecimal number system. Yesterday we have learned about the octal number system. So let us just take a summary of it. So as what we have discussed till now, that is the binary number system has two symbols, that is 0 and 1. That are the two symbols. And octal number system have 8 symbols. So total, that is 0, 1, 2, 3, 4, 5, 6, and 7. So these are the symbols that we use for the octal number system. Let me just format this a bit. Okay, so and then we have something called as the hexadecimal number system, children. Now please understand, computer only understands 0 and 1, but we have this octal number system and the hexadecimal number system for designing the circuits, for doing the electronic work, because that's very much required. And if you in future are going to go into system programming, now there are various types of programming also, right? Depends on you what you want to become. Like you can become a simple application programmer. So in that case you will be developing softwares for your clients, or you can be a system programmer. And as what we have learned in the software concept chapter, that a system software is a software which is interacts with the machine, which is made for the machine. So if you are a system programmer, in that case maybe you're going to develop some softwares for a washing machine, for some some kind of electronic device, because in today's time in every electronic device we have a program that is feed into that particular machine. Even the example that I gave was the washing machine. So we kind of set the program in a washing machine, and then the washing machine takes the instructions, and what program you had set, according to that the machine will function. Similarly, in example is like the aeroplane. In aeroplane also we have something called as autopilot, which the if the pilot puts the plane on autopilot, means the plane is going to fly it on itself, so the computer is going to take control onto it. So it depends, if you become a system programmer in future, which is the most toughest programming, I would say, in that case you are going to make use of the hexadecimal number system and the octal number system, trust me, because you're going to access the memory. And when you're going to deal with memories, you're going to access the memory blocks, what I mean to say. So that will be in form of hexadecimal number system. You remember I told you about the assembly language. Assembly language is a language which is used for system programming. So when you deal with assembly language, you're going to make use of a lot of hexadecimal number system, because hexadecimal number systems, like maybe they look short, but the binary form of it is very long. So to represent huge streams of binary numbers, the we use the hexadecimal number actually. Okay, so hexadecimal number system, children, just a minute. Okay, the hexadecimal number system, we have total 16 symbols. So I'll write it over here, that is hexa, and the symbols we have is 16, and these are 0, 1, it goes till, it goes to what, it goes till 9. Okay, it goes till 9. I'll just zoom out a bit. So 0 to 9. Okay, and then comes the alphabet A, B, and I'm going to stretch this to, okay, anyway, C, D, E, and F. Should have had this in capital anyway. Okay, so these are the numbers. So these are the 16 symbols, 0 to 9. So total 9 symbols. And then this is 10, 11, 12, 13, 14, and 15. Okay, this is 10 symbols, 0 to 9, right? We are starting from 0. So 10 symbols over here. Then this is 11. 12, 13, 14, 15 and 16. So total 16 symbols we have in hexadecimal number system. Okay, now that you know that there are 16 symbols in a hexadecimal number system, so we are going to do is go back to what we were doing, that is converting a decimal number into binary. We have learned that we are going to convert the decimal into octal and decimal into hexadecimal. So let me just have this is a PowerPoint presentation for you. So children, for example, if the decimal number is 87, decimal number 87, I want to convert this 87 into binary. Okay, how I'm going to do that? I'm going to keep on dividing, consecutively divide the number by 2. Why 2? Because the base value is 2. The base for binary is 2. The same thing if I want to do it for octal, I'm going to take this decimal number and keep on dividing it by 8, the base value of octal. And the same thing then follows for the hexa. So the rule is same. So if I want to convert this 87 into hexadecimal, so I'm going to divide that by 16. So this is like 87, so 2 4s are 8, 2 3s are 6, the remainder is 1. Okay, just few students who are not able to just maybe take a bit of time to understand, so let me just go through it a bit slowly. So 2 4s are 8, 2 3s are 6, 1, that is the remainder. Then 2 2s are 4, 2 1s are 2, again the remainder, so 2 21s are, that's how it is, 1, the remainder is 1. Then 2 1s are 2, so that is simple as 2 10s are 20, remainder is 1, isn't it? Then 2 5s are 10, the remainder is 0 at this time. 2 2s are 4, the remainder is 1, 2 1s are 2 0, and at last is not divisible, just take this remainder. So 1 0 1 0 1 1 1, from bottom to up, again and again I'm repeating, this is the most significant bit, this is the least significant bit, so you have to take from here. So the answer is 1 0 1 0 1 1 1. That's the answer. So decimal of 87 is in binary is this number. Fine. And please remember, binary numbers have two symbols, so we cannot have anything other than 1 and 0. Okay, please understand this. Same if I want to convert this decimal into octal, I will divide it by 8. So this is 8 tens are 80 straight away, 8 ones are 8, not divisible 0, 8 tens are 80, remainder is what, 7. Then this is 10, so I am going to divide it by 1, remainder will be 2, this is not divisible, take it as it is. So the answer is 127. Most significant bit, least significant bit, 127. That's the answer. So if I convert 87 into octal, so the answer is 127. And you can see that we can never have any symbol other than 0 to 7. We cannot have 8 or 9 over here. Okay, same goes to hexa. So if it is hexa and 87, so I divide this by 5, so 16 5s are 80, remainder is 7, and then this is not divisible, straight away I took 5, so 57. Okay, now there might be certain cases where the remainder will be 10. Okay, the remainder will be 10. So in that case, 10 basically, if you go to the hexadecimal number system, is this one. So that 10 is actually A. Okay, A. So you can write your remainders out here. Anyway, in the next class we'll take some more examples. Okay, so you can take remainder as 10, but when you write the answer, that 10 means A. Okay, we'll take some more examples, do not worry. So this is just a basic idea that I wanted to give. So any decimal number, convert to binary, divided by 2, decimal to octal 8, decimal to hexa 16. Fine, decimal start with the decimal, so always you have to apply this rule. Divide from decimal, if it is decimal first, then this rule. Remember it, okay? Okay, now let us go what if I want to do it the reverse way? For example, I want to convert this binary number, that is 1010 and 111, into decimal, binary to decimal. Okay, what we did was decimal to binary, now binary to decimal. What rule will we follow? And there is one rule, and that's the same rule that we are going to do. If we, the same rule that applies from binary to decimal, the same rule will apply from octal to decimal and hexa to decimal. Fine. So let us check that rule. So this is the binary number. I took the same number 1010111, and if I really want, if you convert this binary to decimal, okay, this is decimal to binary, binary to decimal. So if I convert this binary to decimal, I should get 87, right? Because I converted 87 into binary, and if the same number I convert back to decimal, I should get 87, right? That is the rule. It should happen. So I have the same number 1010111. Now if I convert this into decimal, I should get the number 87. How to do that? Just simply write this number, give some space, that is, see, 1010111, and then you have to start from the right hand side. Okay, the first rule, you have to start from the right hand side. So you will take this number first and not this. Okay, you will take this number first and take that number, multiply by the base value of binary, that is 2, and start, give it a power of 0. That's the starting number. It will go from 0 to n will be the n digit. So 1 into 2 raised to power to 0. Okay, I took this number 1 into 2 power to 0. Then I will take the next number and same thing I will do 1 into 2, but this time the power will increase by 1. Over here it was 0, over here it became 1, and it will go on increasing. Then I am going to take the third number, that is again a 1, and I will do 1 into 2. Why 2? Is because I want to convert this back to decimal, so I am going to take that base value 2. So 2 raised to, over here it was 0, 1, 2. So every digit we are going to multiply by 2 to the power 0 to n. Okay. Then I'm going to take this 0. This is anyway going to be 0. 0 into 2. And you can see the power has now become 3. Right? So that's 3. And then comes 1. 1 into 2 raised to 4. The power is increasing 1 by 1. That is 0 into 2 raised to 5. You can see the powers 0, 1, 2, 3, 4, 5. 0 into 2 raised to 5. And then 1 into 2 raised to 6. So I took this 1 into 2 raised to 6. And that's what we need to do. Over here it is 5, and then we are going to come up with the answers. For example, 1 into 2 raised to 0, that's 1. 1 into 1, so the answer will become 1. This is 2 raised to 1, this will be 2. 2 into 1, that is what? 2. This will be 2 2s are 4 into 1, so this is going to be 4. This is again 4, that is 2 2s are 4, 4 2s are 8, and it is into 0, so this is going to be 0. And this is 2 raised to 4, so 2 2s are 4, 4 2s are 8, 8 2s are 16, and it's into 1, so I'm going to have 16 out here for this. This is anyway 0, completely 0, and this, that is 6, so 2 2s are 4, 4 2s are 8, 8 2s are 16, and 16 2s are 32, and again 32 into 2, that is 64. Okay, that's the value we are going to get. So 64, then we are going to add these numbers. So 64 plus 0 plus 16 plus 4 plus 0 plus 4 plus 2 plus 1. Answer will come down to 87. So if we convert the same number back to decimal, we are going to go back to the same number, that is 87. And we can cross check this way that whether the answer is right or wrong. Right? So this is the technique, children, you have to use, and the same rule will follow for octal and hexadecimal. Now how are you going to convert? If I want to convert the same number, that is 127. What is 127? Why I took 127? Because I converted decimal 87 to octal and the answer was 127. So again I am going to convert 127 back to decimal. So I should get what? I should get 87 again. And the same rule is going to get followed over here. That is, if I convert 7 into 8, why 8? Because that's the base value. Power is 0. So 7 into 8 raised to 0. Then I will take this number 2, then into 8 raised to 1. Isn't it? And then I'm going to take this 1 into 8 raised to 2. You can see the powers are increasing. So octal to decimal, octal, so 8. Okay, so this is 8 raised to 0, 1, so this is going to give me 7. This is 8 raised to 1, so 8 into 2, this is going to give me 16, and this is 8, 8, so 64 into 1, so that's 64. So 64 plus 16 plus 7, so 64, okay, 64 plus 16, so that's 80, and 7, that is, add those numbers and you're going to have 87 again, right? So octal to decimal, this is the technique that you are supposed to use it, children. Fine. And at the last, the hexa 57. I took 57 because decimal 87 into hexa is 57, and again I'm going to convert back to 87. So same technique. Now this is hexa. What is the base value? That is 16. So I will take, again I'm repeating, always you have to start from the right hand side. So I will take 7 first. 7 into 16 raised to 0 plus 5 into 16 raised to 1. So this is 7. Sorry, this will be, yeah, this will be 7. 16 raised to 0. Any number power to 0 will be 1. So that becomes 7 out here. 7 into 1. And then this will be 16 into 5, that is 80. 80 plus 7, again it comes down to 87. So this is how you are going to convert the hexa into decimal. So children, what did we learn today? Okay, I'll take it back again from the beginning. I'll run this PowerPoint presentation. So any decimal to binary divide it by 2, decimal to octal keep on dividing by 8, consecutively divide by 8, and decimal to hexa 16. You have to just keep track. Okay, you know, during the exam it happens, a lot of confusion happens. So decimal to binary, decimal to octal, decimal to hexa. It's very clear, simple. If you just focus, it's pretty simple. And then binary to decimal is what we're going to apply this technique, right? Then octal to decimal, same rule. And then hexa to decimal, the same rule, isn't it? So hope children this is very much clear to you. I am going to give you some homework today, and please do that homework. And when the window is open for you, please submit your homework in form of the PDF. So this is the small activity that we did today, children. I will be giving some exercise part to you. Please do that, and also do this into your fair copy. I know yesterday I said that I'm going to give you some exercise, which I did not. No issues. Today I'm going to give it to you. Do this exercise in your fair copy, and also you know, if possible you can just take a photo of it, or and you can just convert that into a PDF and can send it to me. Okay, so that's it, children. Please do this, practice it. It requires a bit of practice, and yes, you need to be good at calculations during the exam. If there is some problem with the calculation, so you're not going to get some marks will get deducted for that wrong calculations. Okay, but procedure, remember the procedure, and do the calculations right. Keep a cool head during your exams. Okay, so anyway, again I repeat, for the syllabus point of view, for your upcoming exam, you really don't have to do this, because that's not the part of the syllabus for your upcoming exam. That is the unit test. So you will be only having the software concept. So that's a completely a theory chapter. So you can easily just I had discussed the 5 question answers. Other than the 5 question answers, children, sorry, 10 question answers I had discussed. So other than the 10 question answers, please read the chapter as well, because the question can be asked anywhere from the chapter. It's a completely theory chapter. Please do it, children. So there is only one chapter, software concept, for your unit test. Again I repeat, only one chapter, software concept, for your upcoming unit test. Number system is not there. Number system is not there. Okay, I hope now everything is clear to you. So please prepare your first chapter, that is software concept, and please do this homework. Okay children, bye.